Hello, everyone. My name is Rugozeno Chuse, and I am one of the regional manager with GSDC. I thank each and every one of you for joining the second day bootcamp with us today. We are streaming live on LinkedIn, so you can share it with your friends and colleagues if they wish to join us. The link is on the chat box. So we will adhere by the time. So let me quickly start with an introduction to GSDC. So the Global Skill Development Council, we are also known as GSDC, is an independent organization. And we are recognized by leading MNCs and multiple global universities. Our portfolio includes DevOps, Agile, L&D, Six Sigma, and much more. And till today, we have certified over 90,000 professionals worldwide. And we have also partnered with more than 50 global training organizations, and we call them as GSDC Accredited Training Organization, ATO. We also have more than 50 advisors and SME from over 30 countries, and they are the subject matter expert who creates the curriculum for us to stay up to date with the current market demands and learnings. And they are academic affiliates from prestigious universities such as Yale, MIT, Stanford, Wharton, and Harvard. And GSDC is also a proud member of the American National Standard Institute, ANSI, and the Accreditation Board for International Certification Bodies. We, as an organization, we also work with multinational companies such as PwC, Visa, DXC, and these are the organizations who believes in us to certify their employees. And coming to the GSDC SRE certification scheme, we have SRE Foundation and SRE Practitioner. With that, we will help you with complimentary SRE learning videos, talk series, mock exam, and exam voucher with 2 attempts and global case studies. And on clearing your final examination, you will receive GSDC badge and GSDC digital badge and certificate. And coming to the exclusive license that we have, which is the lifelong membership. Here we have 6 major benefits that we provide our members. So we GSDC conducts a lot of physical summits, workshop, and boot camps. So you will get invitation for this in case if you would wish to join any of the summits, boot camps, or the workshops. And as per your experience, you will also receive invitations to become a speaker and be a part of any of our physical summits or webinars or workshops. With that, you would also receive GSDC access to GSDC Learning Club. We also have newsletters and downloadable resources in the form of templates, which you can edit and use it in your everyday life. Coming to the major and the most beneficial benefit that we provide, that is the complimentary upgradation to the certificate. So just in case if there is any new version in the market, and if you wish to upgrade your certificate, then you can upgrade it for complimentary. And for this, you will just need to sit for the exam. And I also request you to like our page on LinkedIn and as well as our GSDC website. Yesterday, we had a quick 3 to 4 minutes gamification where because Sharma was the host, and we did checked the results again from the back end, and we found out that Mr. Joe and Miss Rashmi are the winners for yesterday's game, and they had the exact number of correct answer and exact number of time. So we will also be having a small game tonight, so please stay tuned and win a voucher worth $400. Coming to the man of the day, we have Mr. Bruce here. He is the SRE director at Google, and Mr. Bruce had the opportunity, the unique opportunity to learn in the seminal term that initiate the SRE movement, and we are hoping to have a great session with him today. Mr. Bruce, you are welcome to our second day SRE Bootcamp. You can have the screen for yourself now. Thank you.
Hey, hi. Actually, I need to give a little correction. I was at Google, but I left Google 3 years ago, and I started an SRE consultancy, and I worked with other companies since then for a major cloud vendor in particular, and for a very successful UK fintech. And so I will give a case study actually that illustrates some of the work I did with them.
Mr. Bruce, thank you so much for correcting me here. And I hope everyone who joined us today will have a great learning, and we will have a positive interaction today. Thank you.
Thank you. And so with that, I will try to share screen. Can you see the presentation?
Yes, we can.
Thank you.
Yes.
Thank you. So in this presentation, I will cover, it will be essentially a case study of something I did for one of my customers, where we took them from a situation where they were experiencing weekly outages in their main product to 5 nines. And so I will cover the case study itself, which is really, what was the situation, what did we do, what were the various steps. And then after that, we'll reflect on it together. You will see there will be a few surprising observations. And after that, I'll move to, sharing some personal experience about challenges when you implement SRE in an organization, because I've been creating several SRE organizations, or I've been taking over some organizations that needed improvements. And so I will share some of my personal experience, and then we'll have a Q&A. So if I dive into the case study itself, let me first give you a bit of context and tell you what was the situation when my customer hired me. So it's a customer that does some credit card payment machines. So those terminals where you put your credit card, you type your code, and hopefully it does a payment. So they write the software on those machines. They don't write the hardware. They buy the hardware from a supplier. And then they also have a complicated payment service that is running in the cloud. It's made of many microservices that I will not detail here. And then those payment services, so they receive the query from the terminal. And then they look, well, is it a Visa card, a MasterCard, or an American Express, whatever? And they send the query to what is called a scheme. And a scheme, it's the likes of Visa, MasterCard, etc. So this service, it will receive the query, interpret it, send it to the right scheme, tell it, hey, can I accept this payment? And the scheme will say yes or no. And then it will send a reply back to the terminal and to the user. That's what their service is supposed to do. And their customers, well, it's the local butcher, it's restaurants, these are their customers. So when I arrived, they were having about 1 outage per week. Most of the time, it was in Saturday afternoon, which was the peak traffic time for them. It was when they had the most activity. And those outages were sometimes detected by the customers themselves. It would happen quite often, actually, that they wouldn't notice, and customers would call the customer support service, and that's how they would find out that it's broken. Or they also had some form of alerting, but it was a very limited form of alerting. They had, basically what they were doing was sending to a Slack channel. They would send whenever there was an exception in their log, an exception stack trace, they would send this to a Slack channel. And so the Slack channel was very noisy. It was not a very good signal. So typically when it was breaking, it would take about 5 minutes if they were lucky, 20 minutes if they were not lucky, to find out that there was a problem.
अभी ये कॉल खत्म होगी ना तो एक गेम होगा, अगर उस गेम में हम जीत गए, गेम एज इन क्वेश्चंस पूछे जाएंगे.
Yep.
I am ready for that, Mr. Bruce. I request all the participants to keep your mic on mute. Till then, we will have a Q&A question at the end. So thank you so much.
Sure. So now some additional context. When they would receive those messages on Slack, so hopefully some available engineers would jump in. There was no, formal responsible person. It was just, well, they would hope that some engineer would see it and do something. And they would usually jump on calls, usually run by the CTO of the company. And so you would see those Zoom calls with about 5 to 10 people. Who were those people? Well, those who happened to be around when the problem was noticed. And those people will make, they were from different teams. They would start investigating and making suggestions. It was not really clear who was in charge and who was supposed to move the problem forward. So it would take them about 30 minutes to recover. So basically, every week they would experience between 30 and 1 hour of downtime. So first, we went for some quick wins, the very obvious things. First, we implemented what is called cause-based alerting. You might see some variations of this called SLO-based alerting, but it's a bit the same thing. And instead of, sending alerts when there would be exceptions in the logs or when the mean latency would be high, we would rather look at our causes and say, well, if we have, let's say, a 90% failure rate, then we should alert. And so how we did that? So if I represent how the system worked, we still have the terminal, we still have this payment service, which is made of many microservices, as I showed on the previous slide. And we added those 3 things here in red. We added a metrics service, and that metrics service would help us, to figure out if it was working when the terminal was doing a transaction. Because what we did is we changed the code on the terminal so that each time it would talk to the payment service to do a transaction, then the payment service would reply yes or no, or it didn't work or whatever. Then the terminal would contact our metrics service and say, hey, I just did a transaction and it worked, or I did a transaction and it failed. And this metrics service would aggregate that information, send it to a managed Grafana, and this Grafana would also talk to an alerting service, which we would use to send alert when there were too many failures. So with that, it was a little effort, and we were able to detect with very good quality when it's broken. So we would receive alerts when it's actually broken, and it would never happen that it was broken and we wouldn't receive alerts. So it was a much better, much more accurate detection mechanism. So that's the technical aspect. Now on the process, we also improved how they respond to incidents, and that's not technical, it's just the process. We set up an on-call rotation, so at any point in time, there was one engineer on call, and it was their job to respond to alerts. And they would use, instead of sending the alerts on Slack, with the managed alerting service, we would send the alert to their mobile phone. And so they knew when they were on call, they would receive the alert and say, okay, that's for me to deal with. That was the set of quick wins that we implemented at first. This improved things a lot already, but then we wanted to move to, do better, because this was still not enough. And so this is how we went to 3 nines. First of all, we started to run 2 independent stacks in 2 different cloud regions in active passive mode. So one was taking the transactions, and the other one was here just in case the first one breaks, just to fail over. And we added a failover system. And so initially the failover was manual, it would be one engineer who would take some action to send the traffic to the second region. And then we automated it. So if I draw how it works here, again, I put the new things in red. So we still had our Grafana alerting thing. We still had this payment service that was the one we had in the beginning. We moved the metrics service to another region, and we turned up a fallback payment service that we would use when the first one breaks. And we created those 2 things. The first is a failover controller, which would talk to the metrics service. And when the metrics service was saying, well, the primary payment service, it doesn't seem to work, well, we would trigger a failover to use this fallback payment service. And how would we trigger the failover? By writing what I would call an endpoint switch file, which was a file that the terminal was frequently reading to see, well, which endpoint should I use? That one, the primary one, or the fallback one? And this way, when the primary was breaking, the metrics service would notice it, the failover controller would change the file, and the terminals would go to the fallback. So that was just fallback automation. That's the technical aspect. Again, there was a process aspect to get to 3 nines, and it was to stop those calls with 10 people doing things with, it was not clear who was in charge. It was not clear who was leading the investigation. It was not clear who was taking the decision of let's fail over, let's not fail over, let's take action or not. So we defined clear ownerships of various services, and we said, okay, you own this, you own that. And when your thing breaks, well, your on-call person will investigate. And until they ask help, others don't bother them and don't get on a call, because if you're on a call, you cannot investigate during that time. And so that was the process part of it. Now, I have a question for you. I will be happy to read answers on the chat. It's, why are the metrics service and the failover controller in the fallback region? So, we had the 2 regions, right? The main region and the fallback. And the metrics service and the failover controller, we put them in the fallback region, not in the main region. Do you have any guesses about why? Yeah, with the first answer.
Because it's get identified that where is the failover, so that switchover can be done immediately and services can be restored.
Yeah, it's for high availability, but if you remember, we have only one metrics service and one failover controller. But you're right, it's largely for region availability, because if the primary region breaks, we need the metrics service and the failover controller to work. That's exactly when we need them. While if we have the failover controller in the primary region, when it breaks, well, it will not fail over. That doesn't help. So we really needed to have it in the failover region, not in the primary. But yeah, good answers. Thank you.
That's correct. Yeah.
Now I'll move to the 4 nines iteration, how we went to 4 nines from here. So technically, and this time it's only technical stuff, we run a third stack on a different cloud. And why did we need to do that? Well, because cloud providers, actually, they don't really provide 4 nines. So if you're using only one cloud, it's rare, but it happens, let's say, once every 18 months that they will have a global network outage where their entire cloud is unreachable. And so, well, during 1 hour, you cannot use their cloud at all anymore. So if you really want to be 4 nines, you actually need to have 2 clouds. Another thing that we did is that since some of the breakages were due to new releases, we would canary the new release in one of the regions. Since we had 2 main regions in the primary cloud and a third region in the secondary cloud, well, we would use one region to send the new release, give it 5% of the traffic, let it run for a while, and when we were happy, we would increase the traffic and generalize the release. And we also did, since our stacks were active passive, there was one working and other stacks doing nothing, just waiting for a failover. We would implement synthetic monitoring to monitor those stacks, to send them a bit of fake traffic, just to make sure they were working. Because usually something that is passive, if you never use it, when you need it, it's broken usually, because something changed. It was working when you turned it up, but then it changed. And so if I draw you again what is new, with what is new in red, so we still have all the same systems, that part doesn't change much, but we have a new cloud here. And in that new cloud, we have our failover of the failover service. So, you have your primary payment service, you have the fallback one, which is in the same cloud in a different region. And here you have a new payment service, which is in a different cloud. And why is it a last resort that we use last? It's because, it was hard to port the application to another cloud, so it didn't have all the functionality. So ideally, we didn't want to use it because it doesn't work as well as in the other cloud. It works, but some things will not work. What else did we have? We had a second switch file, of course, so that we have the switch file available in two clouds. And the failover controller, when it would write the switch file, it would write it to both clouds at the same time. And the terminal would also try to fetch it from both clouds. It didn't care which one it got, as long as it got one. And we also had this little prober for the synthetic traffic, which would be sending traffic to the fallback payment service and to the last resort payment service. And although I didn't draw it, it would also send traffic to the primary payment service. And this way, if those services were broken, if the failover was broken, we could have an alert and go fix it before we actually need it. Which brings me to one question, and again, we can put answers in the chat, is why do you think we used switch files rather than a cloud load balancer, which would be more classic?
So it should have the same data on both the cloud. When the failover is happened, then it gets synced immediately and the services will not get impacted.
Yes. Yeah. Exactly. Yeah. We have a very good answer. Thank you, Rashmi. We have a very good answer on the chat. It's hard for a cloud load balancer to switch to another cloud. Google load balancers, basically, they are meant to switch Google traffic. And another reason is that if we have a cloud load balancer, if that cloud goes down, well, it doesn't help. We're still doomed. And so since the whole point of doing this is to keep working if one of the cloud completely dies, well, we cannot depend on a cloud load balancer that is in a single cloud. And on top of that, a cloud load balancer, it would be a single point of failure. So very often you will see cloud vendors tell you, my cloud load balancer, it has a 5 nines SLA. But if you have seen a cloud vendor who really meets 5 nines, please tell me and I will go sign with them. So that were the main reasons. And we also wanted to anticipate on our next step, which is the 5 nines step. And so what did we do for that 5 nines step? So the load balancing, we moved from failover, active passive, to active active. So we started doing load balancing between 3 active regions in our main cloud. And then we still had the other cloud for disparate situation with failover. And we also implemented automatic draining. So when one region would break, we would drain it automatically, which means stop sending it traffic. It's a bit the same as failover, but because it was active-active, we were able to, and because we had 3 regions, we were able to do it much more aggressively. We could, at the first sign of a problem, don't ask 20 questions, stop using that region. And it would also slowly undrain automatically. So when we would drain a site because it didn't work, it would slowly try to give it just a little bit of traffic and see, does that work? Yeah, if it works, keep going, give it a bit more. If it doesn't work, well, redrain it immediately. And that's something we couldn't do before with our implementation of failover, because our implementation of failover, it would just fail over once, and then it wouldn't do anything anymore. It would say, well, I don't know what to do. It would send an alert to a human and said, okay, I did a failover, now it's your job to go back to normal. While with that system, yeah, we could drain, it wouldn't drain automatically. So, we could really drain very early, very aggressively at the first sign of problem. We also needed to put our traffic controller and our metrics service on 2 clouds, which we didn't have before. And we also implemented an automatic failover to the second cloud, which fortunately we never actually triggered, but it was here in case the first cloud explodes. And so again, I'm putting the new things in red. So what did we have? We would have one new region in our primary cloud, so that we had 3 regions in our primary cloud. And we would have this auto-drainer thing, which was a replacement for our failover thing. But we would have a second of it. We would have 2 of them and running in different clouds. Same for the metrics service. We would have one in the first cloud and one in the second cloud. And the terminal would report the metrics to both metrics services for each transaction. So each transaction, both metrics service would have the information, and both auto-drainers would look at the metrics service, and both auto-drainers would coexist, and they would be both able to write the switch file. And that's how we went to 5 nines with an active system with all payment services in the first cloud processing payments at the same time. And this fallback here, last resort, in case this first cloud was failing. Now the question is, okay, it's nice you have 2 auto-drainers and 2 metrics services. So it's possible that they have different information, and it's possible that they make different decisions, because, you know, if you have one of your clouds that has networking problems, it will not receive the same data. If you have a cloud that is a bit flaky, they might, you know, have a few discrepancies. So how can we make them coexist, those two auto-drainers, you know, when they will write something? How did we do to make sure that they would agree, or that if they disagree, we take the one who's right? And so here is how we did. First, we said that each auto-drainer will use only the metrics service that is in the same cloud. So the auto-drainer in the first cloud would use the metrics service from the first cloud. The auto-drainer of the second cloud would use the metrics service of the second cloud, but they wouldn't talk to the other metrics service. Then, when the auto-drainers want to write the switch file, before writing it, they will check a few things. They will check how old the switch file is, and they will also check how many data points were used to create that switch file. So when an auto-drainer writes the switch file, it will say, you know what, from the metrics service, I got that many data points, that, you know, I made that decision based on X amount of data, and it would write that amount in the switch file. This way, auto-drainers could reread the switch file and be like, that one made a decision with 100 data points, but I have 1,000 data points. So I know better. And so I can override the switch file because I have more information. While if it had roughly the same amount of data points and the file was recent, it would say, well, okay, I'd better not touch it. It's probably the other auto-drainer who wrote it. The other auto-drainer has as much information as I have. Okay, I will not touch it. And this way, we had our 2 auto-drainers coexisting. And if one of them was failing, well, the other one would take over transparently. This creates a problem that with that logic, it's possible that the first auto-drainer is constantly active, and the second auto-drainer is always like, oh, the file was written recently, so I will not touch it. And that would be a problem, because it would mean that the second auto-drainer is almost never doing something. And so it means that if the first one breaks, it's probably at that moment that we will discover that the second one has been broken for 2 weeks. So we also added a bit of logic so that once in a while they would switch roles to make sure that every day both would be used. And this way, if one would break, well, we would be able to take action before it was a problem. So that's the whole story about how we went from, you know, 1 outage per week to 5 nines. I'm happy to report that over the last 12 months, there were 0 outages. And now I have a few reflections to share. The first one is, it's actually an interesting point. What do SREs usually do? You know, when you're being told what is an SRE, what is an SRE job, you look at an SRE job description, you look at what SREs do in most companies. What are SREs doing? We can put some answers in the chat. It will be interesting to see what everybody says. Well, we don't see so many answers. So I'll give you the answers that are the most common in the industry. So usually what people say that SREs do is, well, they do automation. They work on CI/CD, Jenkins, Ansible, they do some Terraform, that kind of things. They also do some monitoring. They create some dashboards, they create some alerts, they define SLOs, they run the infrastructure, Kubernetes, virtual machines, that kind of things. But the developers run the application, the SREs run the infrastructure. Or sometimes you will see some people telling you, they create a platform and a middleware that the developers can use to be more productive. Or they do some load testing and some capacity planning, or some chaos testing, or other forms of testing. That's the industry widespread answer to that question. What do SREs do? Now, is it what they did here in that journey that I described? Well, let's take a look point by point. Did we do automation? Not really. We did zero CI/CD, no Jenkins, Ansible, Terraform, just a few lines of Terraform to create the services, the new services that we created. But yeah, we were definitely not working on CI/CD. Monitoring, not in the usual sense. We did very little dashboards and alert work. We created, one or two new alerts, the ones that were symptoms-based with the probers. Maybe we modified a few dashboards, but it was a very little part of the work. The real monitoring work that we did, it was creating this metric service and modifying the code on the terminal so that it would talk to the metric service. So yes, arguably it's monitoring, but not in the usual sense of the term. It was not just doing Grafana and setting up alerts. Define SLOs? Nope. We barely did any of this. We just had very brief conversations to reach to the understandings that we wanted for our 5 nines, but that was pretty much it. Run the infrastructure? No. You can see in the previous slide, we didn't do much Kubernetes or virtual machines work or anything like that. Sure, we turned up the service in a few places, but we didn't have a separation. SREs do infrastructure, developers do application. No, SREs were just touching everything. Did we create a platform and a middleware? Absolutely not. Did we do some load testing and capacity planning? Not really. Yes, at some point we did 5 minutes of capacity planning, and it was really 5 minutes over several months. Did we do some chaos testing? No. So we didn't do any of the things that the industry usually says SREs do. Instead, what did we actually do? We changed the process, we changed the design, and we touched the implementation of that design. That's what we did. And that's what is SRE work at companies like Google, Facebook. That's what the SREs do there. Yes, they also do a lot of those things here, but they don't limit themselves to those activities. They do whatever needs to be done for the service to be available, and very often it starts by changing the design and or the process. And so that brings me to what an SRE really is, and that's a very common misconception in the industry. SRE, it means Site Reliability Engineering. The important word here is reliability. So SRE, it's about making services work end to end, doing whatever it takes for a service to work. And so an SRE team, when it's effective and when it reaches that result, it's not a CI/CD team, it's not a Prometheus team, it's not an infrastructure team, it's not a load testing, not a chaos testing, not a whatever testing team. It's not a team that defines SLOs that nobody will read. It's not a team that just carries the pager waiting for problems to happen. It's really a team that will do what it takes to make the service work. And if you limit your SRE team to those things, which is unfortunately very common, that's often what happens when my customers bring me in because they're struggling with their SRE efforts, they're not seeing the results that they were hoping to see. That's very often because they box their SRE team in those activities. And so that's really important to be able to be holistic and to cross teams' boundaries to deliver the results that you expect if you read the SRE book. Now, that brings us to a first takeaway. If you successfully implement SRE in a company, your SRE team will think end-to-end user experience. They will not be within an infra or application or an IT versus dev box. To them, it's irrelevant. They will be thinking holistically about end-to-end, does it work? And if I need to touch the infra, I touch the infra. If I need to touch the app, I touch the app. And that you can do either with an SRE team, or you can get the development team to do it. That's the Amazon model. At Amazon, they don't have SREs, but they apply SRE principles. It's just the developers who do it. And the second thing that SRE teams do is, as you can see in our case study, it's more important to get fast results than to get beautiful theory or an elegant solution. What we did, when you think of it, was not very elegant, right? We didn't use the classic things. We didn't use a cloud load balancer. We could have done things differently. We went just as fast as we could to something that would solve the customer problem. Now, another surprising takeaway of this, the first one was basically we solved the problem by not doing any of the things that SREs are usually said to do. And we did the things that they do in just a few companies, which are the most successful. A second surprising thing that you can draw from this is if you look at which of our actions had the most effect and how much effort those actions took. So I did it. I did an evaluation. So, we had multiple actions in that journey. And so I looked at how much those actions reduced the weekly downtime or monthly downtime and how much implementation effort they took. And so 2 actions actually did already 55% of the downtime reduction. The first action, it was to set up an on-call rotation, stop sending alerts on Slack, instead sending them to the pager, to the pager of on-call engineers, and to implement synthetic monitoring that would give us a very good signal rather than plenty of stack exceptions on Slack. And the second action, it was to bring some order to the calls, those calls where they would have 10 people doing semi-random things, convincing them to stop doing that and instead let the on-call person do their job. And it was hard. It was a hard convincing effort to get there. But those 2 actions together, they already did 55% of the effect on weekly or monthly downtime. And how much effort did it take? Well, bringing some order to those calls, it was technically 0 effort. It was a lot of discussion and convincing, but once the decision was made, implementing it was nothing. It was, okay, done. We stopped doing that. The only real work here, it was to set up the on-call rotation and to create the synthetic monitoring, which over the whole project was about 3% of the total effort of that whole journey. So 3% of the effort had 55% of the effect on the downtime. Now, if you look one step further, there was another part of the effort, which was to set up 2 regions, make it work in active-passive mode, automate the failover. That did another 22% of the effect on the weekly downtime. And the implementation effort, compared to all the rest, it was about 6.7%. I counted the weeks we spent on it. And so, if you combine those 2, the first thing and the second thing, you have 10% of the effort, approximately, for 77% of the effect. And when I say 10% of the effort, I also mean it was 10x faster to do that than to do everything else. So you can get very significant gains very quickly if you prioritize really aggressively. And that's my second takeaway. What successful SRE implementations do is when they face problems, they will ruthlessly prioritize the critical efforts that will have that kind of massive impact. And they will defer everything else. Everything, when somebody will come and say, oh, we should do this, it's best practice, they will say, well, wait a minute. If we look at the problems that we have now, and we implement that best practice, what will actually be the effect? And if the answer isn't a massive effect for low effort, well, they go look for something else. So always before implementing, they challenge, well, what will be the effect? Even if it's best practice, what will be the effect? And they look for, they settle for low-hanging fruit that will have very high impact rather than for perfection. By which I mean, perfection, between quotes, it would have been, well, going active, and multi-cloud from day one, but it would have taken quarters. While setting up an on-call rotation, well, it pretty much took us 1 hour. And so, you grab the low-hanging fruit and you iterate. Now I'll move on to challenges that you have when you implement SRE, and that's challenges that I frequently observed, with my customers. What happened when they try to jump in the SRE bandwagon. First, there is a technical challenge, and that one it's really for individual contributors and engineers who work on it. The first thing is that the quantity of best practice that you will find on the internet, it's overwhelming. There is plenty of it. There is a million recommendations of do this, do that other thing. It's really hard to prioritize and to figure out where to get started. For example, you will find some recommendations of, you should do load testing. But if you're implementing load testing, it will probably take you some work to automate, to create a load testing system. It doesn't come easily. It will take you at least weeks, if not months or even quarters. If you don't even have an on-call rotation yet, you will have much more impact by setting up an on-call rotation, and it will take you about 1 hour than by implementing a complicated load testing system. So, it's hard to pick and prioritize those best practices. A second challenge is that the most important principles, they tend to be very counterintuitive to most engineers. In that example that I described with my customer, most of the developers, when we were telling them, we'll do this synthetic monitoring, we'll create a metric service, we'll do the redundancy, in their mind, what we needed to do to improve the availability was completely different. They wanted to do more testing, they wanted to create some caches, they wanted to get rid of PubSub because PubSub was creating issues. It was super counterintuitive to them when we were telling them, you know what? We don't care about why a particular region breaks. What matters is to have 2 regions, and when one breaks, to be able to move to the other one. It was really hard for them to get to that mentality. Another part is that's a bit what I described before in the takeaways. It's that there is a lot of misunderstanding of what SRE is from management, from other teams, and it leads to getting individual contributor boxed into tasks that are not necessarily the key tasks. It's rare that an organization understands that SRE needs to change the design. And so usually many individual contributors, they find themselves boxed into writing YAML file, doing CI/CD, adding a bit of a graph here and alert there, but not the real transformational changes. And so here I provide a few tips to help with this challenge. The first thing, I already mentioned it, but it's important to repeat it. It's before taking on an effort, question it. Will it really improve the end-to-end experience? If you implement that thing, will it really make a big difference? If you look at the last, 3 months or 6 months of outages, if you had done that effort 6 months earlier, would it have avoided the outages? Yes or no? Another tip that I give is to focus on the principles. If you're reading the SRE book, understand the design principles, understand why they do what they do, understand in that presentation, why we did the redundancy the way we did it, why we placed that service in that particular region. It matters much more than being a superstar of Terraform or of Prometheus. Another thing is learn to code. You can see that the actions that we took to stabilize the system, it was, implementing a metric service from scratch, which was a service reachable from the internet. It was doing some redundancy. It was writing some files to cloud. You cannot do that kind of thing just with Bash and YAML. So to be successful in SRE, it's important to learn to code in, at least in Python, if not in one of Java, C++, Go, that kind of languages. I also recommend to seek advice and mentorship from SREs who have done it in the best technical organizations. Because, when you see all your organization is boxing you into doing CI/CD, YAML, Prometheus, that kind of thing, seeking advice from SREs who know what success looks like, it's invaluable because they can tell you what's the difference between what the activities that you're doing and the activities that they would expect SREs to do in a successful organization. So I think that's the bulk of it. Maybe there is one more. Yes, very important. And actually, it's true about any engineering job, not just SRE, but it's particularly important in SRE. Become good at leadership, influence, and negotiation. There are plenty of books out there. And actually, the real job of an SRE is to do that. It's to influence, it's to negotiate. The amount of time that you need to spend talking the developers out of doing things that will not be very useful and instead doing things that are counterintuitive but will be very useful, that's a large part of the SRE work. Now, if I move on to the management challenge. So the number one key challenge is that the principles of SRE, they are transformational, by which I mean that when you decide to go on an SRE transformation, you cannot just keep your development teams as they are, your IT teams as they are, and just hire some SREs and put them here. That will not be effective. The SREs, they will really need to be able to influence how the development is done, how IT operates. They will need to be able to cross boundaries and to challenge how people work and to propose new approaches. So if you really want to get the benefit out of SRE, you will need to empower them to do that. And that's usually what is very difficult in management. Very often when I'm called, it was by a CTO or a VP who hired some SREs and thought it would do some magic, but didn't support them enough to create the transformations that they need. So yeah, they require, at the very minimum, they need to be able to influence design and the development priorities and the development processes. And building that influence, since it's the very, very hard part that most organizations struggle with, you should think about it first. You should think about how you will do that before you start creating your SRE team. It doesn't mean you need to have nailed it before you create the team, but it means you need to have an idea of how you will do it and when. And the solutions, they vary a lot depending on your organization and on who is sponsoring the project. For example, is it an executive level effort? Is it the CTO who decided to adopt SRE? Or is it a bottom-up effort? Is it, one team who decided, that SRE thing, it seems pretty interesting, let's try to do that. Then your approach to solving that challenge will be completely different. So you need to know where you are, do you have an exec behind it, or is it a bottom-up effort? Another question is, do you have the buy-in from the key stakeholders? Or is it just, you decided that in your team? And if you don't have the buy-in, you should try to go get as much as you can before starting. Obviously, you will need buy-in from developers and IT because they will be massively affected. But sometimes you will also need buy-in from Q&A, from change management teams, from risk organizations, from product management, sometimes from other teams. Try to think about everybody who will need to agree, or at least to not mind too much that you're moving the walls. On top of that, you could see some territorial reactions when you will approach those teams. For example, if you approach the change management team and you start to explain them that you're going to do canarying and that instead of taking of doing very long testing, end-to-end testing and acceptance campaigns, what you will do is take a bit more risk by pushing things more aggressively into production, but you will mitigate that risk by giving the new release only 1% of the traffic. You could have a number of teams telling you, well, that's my turf to decide how that stuff is done. So you have to approach them. It's important to be candid and clear about what will happen, but you also have to be clever about how you will influence them. And many teams, be prepared for that. The principles are very counterintuitive. So be prepared to face a "that sounds all wrong" reaction, even from teams who are not territorial, who will tell you, oh, why are you doing redundancy that way? Oh my God, no, we cannot release something before doing three weeks of end-to-end testing. You will hear that kind of reactions. So you need to have thought a bit about how you will approach it. It's also useful to bring in somebody who has seen what success looks like and who's able to speak about the results and of how it goes. It brings some credibility. And so now with tips to approach it, whether you have exec support or not, I highly recommend to start small, to try the approach on a subset of the organization and tune it, fix it, take the time to convince people to figure out what works and what doesn't. What the exact structure that works, it will be dependent. It's very different in each organization. And you're not too much at risk of making that mistake if you're a small team, if it's a bottom-up effort. But when it's an exec decision, it happens way too often that an exec says, okay, I'm convinced, let's do this SRE thing. And boom, they hire 5 SREs. They want everybody to do SRE tomorrow. And usually it doesn't work. And they realize that they made a massive mistake and they scrap the whole thing, or they call for help. It's also important to iterate. You will not get everything done from the beginning. You will not get it right immediately. It will take some time to build the credibility. So be prepared for a marathon, not for a sprint. You cannot say, well, I will do my entire SRE transition in 3 months. That's completely unrealistic. Be prepared to iterate. It will take 1 or 2 years. And to, get the low-hanging fruits and move on, then maybe spread it to more teams. That's how you can approach it. And you have to be incremental in how you will manage that change with the organization. You do little steps, and you don't come overnight and tell them, okay, guys, we're completely changing the process. Start with one little piece, propose to try it to see the benefits. I also recommend that each milestone, since it will be a marathon, you will define a plan with milestones. Each milestone should provide value in itself. If you have to wait 1 year to see the benefit, at some point you will lose either your motivation or you will lose the support from your organization because they will not see benefits. So be careful that each milestone needs to bring maybe not mind-blowing benefit, but it needs to be a positive. And define the success criteria upfront. So, you have your plan. Of course, you will adjust your plan as things are unfolding, but you start with a plan. For each milestone, you have success criteria. And when you meet a milestone, you can go back to, all the influencers and stakeholders and decision makers and show, well, look, we achieved that milestone. These are our success criteria. We nailed them, or it's failing here. Let's iterate to fix it. Or otherwise, if you're in a situation where everything is breaking all the time and your first obvious milestone is make it stop, well, the second it will stop, you will lose your organization traction. You will be saying, well, I'm working on reliability, but people will tell you, but it's reliable. While very often you have risks under the surface that don't necessarily translate right now into outages, but could in the future. And that's where you need to keep your organizational support to address those risks before they bite. And another very useful thing is to bring an SRE who has seen what success looks like. One from the big successful companies, from the Google, from Facebook, from that kind of company. And so that they can talk to other people to convince them, to overcome objections, to help you a bit when you're stuck. And the problem and where it's difficult is that kind of people are extremely expensive. So it's important when you bring them in to empower them so that they spend most of their time using their unique skills that makes them so expensive, instead of spending 10% of their time doing the stuff that they're the only one who knows how to do, and 90% of their time implementation, typing YAML files because nobody is going to do it. It's important, if you want to limit the cost, it's important to put them in a position where they can guide people and have people execute it. And as people are starting to execute, very often the people who execute, they will have objections. And then you will have that debate between that very experienced person and the people who are supposed to execute. And that's how you will transfer the knowledge to those people. That's due to the debates that happen during execution. But if you leave your super experienced SRE on their own and tell them, well, make yourself useful, you have to convince people, very often what they will have to do is they will have to do the work themselves. And so they will spend 90% of their time doing stuff that anybody could do, and only 10% of their time doing the things that make them so rare and precious. And with that, I guess I'm pretty much done with the presentation, and I'm happy to answer any questions.
Hi. How do you relate between the SRE and your ITIL processes as such, between the two?
So one of the first things is that ideal processes, it depends on which organization you're in. You know, it depends a lot on the culture of the organization. So you don't have like one size fits all processes. And so one of the first things that SREs will have to do, one of the key things they will have to do is figure out what processes will work for the organization. You know, there are a few basics, like, for example, what I explained in the very beginning. How do you respond to incidents? Do you have 10 people jumping on a call, or do you have a clear on-call person who will take ownership and leadership of the incident response until they feel they need help and call other people? That kind of things. So you will have to look at what doesn't work and to devise a process that will work for your organization. So, and that's typical SRE work. Does that answer your question?
Yeah, so it's more of a people management skills. Can we say that way?
Yes, it's both. It's both. Okay. SRE, it's both technical work and not necessarily management, but leadership. And,
leadership, yeah.
And SREs have to think about processes. Now you can split the work between different kinds of SREs. You have some who are more technical and, you know, they don't like that much to discuss processes. You have some who are more in the process, but all SREs, they need to have at least, you know, they cannot be a pure technical player or a pure process player. They always need to do a bit of both. Now they have different preferences. You will tend to find a lot of engineers who are not that much into leadership in that profession, but it's a shame because actually it requires really excellent leadership skills.
That's true. That's really true. Yeah. Thank you so much. Thank you.
You're welcome.
Yeah.
Mr. Bruce, we have a question from Nisha Sharma. She is asking, is it mandatory for SRE to be a basic coder?
No, I have seen some successful SREs who cannot code. It's rare, but I have seen some. At Google, for example, one of my teammates, he didn't want to learn coding. He could write some scripts, but coding was not his thing. Now, you can be successful in the big companies as an SRE who doesn't code. You can also be successful in small companies who are at the very beginning of their SRE journey. But if you really cannot code, you will pretty soon hit limits that will prevent you from doing the kind of thing we did in that example that I showed you, you know, developing a metric service, developing a failover thing. So if you have teammates who can do that kind of thing, then it's fine. But if you have, you know, if you need to be in a significantly sized organization to be busy full-time with tasks that don't require any coding. That said, yes, it's possible, especially if you are in an organization that for now operates in a traditional way with developers and IT. Having IT starting with scripting, you can do very useful work in that setting for years. But I really recommend that over time you get to proper coding.
Thank you so much, Mr. Bruce. And we are running out of time, and we are live on LinkedIn. So you can post your queries on LinkedIn so that your connection and our local global audience can also learn from your queries. So thank you so much, Mr. Bruce, for this knowledge sharing session. And there is one last question. With that, we will end the session here. Ms. Saini is asking, what is the goal of application performance management?
That's an interesting word that was introduced. It's a very fancy way to say monitoring. It's simply to see if the application is working or not. And it's also it's a way to first receive alerts when the application is broken, and also have some graphs that help you debug and figure out why the application doesn't work. Like, it will show you the CPU usage, the number of queries per second, the number of errors per second, that kind of things. But that's a very fancy word to say monitoring.
Okay, Mr. Bruce, thank you so much for this knowledge sharing session. We really did have a great time. And now I call upon Mr. Vikas Sharma, who will help us in hosting the game.
Thanks to all of you for your attention.
So first of all, I thank you, Bruce. That was really very good and very great insight into what SRE role is with that great case study. Thank you. Thank you so much. And now I'm sharing a link that's in the chat box, and you can click on that link. It will take you to the platform where we are going to play a game. And I would just like people to go to that particular link and start using a code. I'm going to share a code with all of you. Just give me a minute. I'll put that code in the chat box. It will ask for a code. That's 1013. That's the code. And please click on that. Please use that code and get into the quiz. And I would share my screen just to tell everyone that what you would see. Hey, where are we? We are here. Well, can you see my screen, Rugo?
Yes, we can see your screen.
Okay. So are people facing any challenge? Team, if you are facing any challenge to get onto that link or using a code, please let me know. I don't see people here. Let me just refresh the page. Oh, yeah, there it goes. Wow. So we can see that there are around 10, more than 10 people playing this game right now. And if I look at the scores, if I just sort it out, so Shiva is leading with 3 points. And then we have few people who have 2 points. So there are total 9 questions, team.
Okay, Mr. Peter and Mr. Shivas, be quick
Yes.
so that you can win a voucher.
Absolutely. And now I see Peter, Shivas, and then we have Surendra and Aldin. They have 3 points. And I see Mark and even Nandini with 3 points. Let me just
be quick because it is time restrained.
Yeah.
Whoever will be the quickest will win the voucher.
Yeah. And team, the time for this game is only 2 minutes.
Time for this game is only 2 minutes. What is the session code?
It's session code. And that's 1013.
Session code. That's 1013.
Okay. So I see few
So
people
I
have
see
completed.
few people.
So team, hurry up, and time is running out. I see there are 4 people who have completed. And if I just look at the leaderboard, Peter with 6 points. Wow, that's amazing.
Yeah, Peter, you can do it quicker.
Yes. I think it's Peter, Aldin, Nandini, and Vinay. They are still playing. Others, most of them have completed. So team, that's really great to see. And then Peter is still leading, 6 points. Great. And okay. So if I just look at people who are playing, Oh, quite a few. Quite a few people who are still playing. Let me just look at the board with the leading points. I think it's Peter. Peter has got 6 points. Others are lagging behind. Hey, Peter goes to 7. Wow, that's amazing.
So time is running out.
Yes, be fast, team, be fast. And yeah, Peter is still leading, 7 points. I see Peter followed by Aldin. They're still playing. And then. Okay, let me refresh it once again. Peter is with 7 points. And how many people do we have? I think people are done. Oh, Peter got 8 points. That's great. So I think it's Peter and Ritesh who are playing. Oh, Peter is done. Peter has got 8 points and Ritesh is the only person who is about to complete. But I think 2 minutes are over.
Yes. So let's
I'll-
just give 5 more seconds so that they can be quick. 5 seconds. You
Okay.
can start the countdown.
Okay, I think it's only Ritesh who's playing. And if we look at the leaderboard, Peter has completed with 8 points. So Peter has won this game.
Yes. You can end the game and let's see.
Okay, so let me
Yeah.
just end the quiz and let's look at it. I've clicked on end quiz. It's taking time. Yeah, there we go. Quiz winners. So winner is Peter with 8 points.
Congratulations, Peter.
So congratulations, Peter. That's wonderful.
Thank you.
Thank you.
Thank you.
Welcome.
Could you please show us your face so that we know who the winner is? We will be grateful for that. And
Yeah,
well,
Hey,
congratulations,
Peter.
Mr. Peter.
great. Wonderful.
Thank you so much.
Yeah.
So you will receive your exam voucher by tomorrow. And thank you so much for playing the game. And thank you so much, Mr. Bruce and Mr. Vikas Sharma for being with us in these 2 days. And it was a really great experience for all of us. We do hope to have you guys in the near future again. Thank you so much. And thank you everyone for attending the bootcamp.
Thanks, everyone.
Thanks,
and have a
everyone,
wonderful time.
and have a wonderful time. Thank you.
You're welcome.